Central heating, introduction to heating systems. At the end of this part of the session, I want you all to be able to state the purpose of heating, as well as some of the key regulations and what those regulations tell us. Recognise the difference between full, selective and background heating, and list the components required for interlock, and we're going to find out what that means as well during the session. Okay, so the purpose of heating systems essentially is to ensure thermal comfort. And there's lots of different things that will affect thermal comfort: radiant heat, the amount of air, the number of drafts there are, as well as the temperature and humidity. All of these things together come together to affect thermal comfort. And the purpose of heating systems is essentially to ensure thermal comfort in an economically efficient way. There are full central heating systems, but we also need to be aware of background and selective systems. Full heating systems heat the whole property to an agreed comfortable temperature, whereas background heating would heat the whole property but to a cooler temperature. They wouldn't necessarily be able to heat the whole property to the agreed temperature when it gets cold outside, essentially, which is when we need the heat the most. Selective heating would be heating which is used just to heat individual rooms or areas. So examples of full, background and selective heating. Well, a full heating system would be a traditional heating system with radiators or other heat emitters, for example, underfloor heating in all areas. Background heating would be similar, but it might have a lower flow temperature or undersized radiators, heat emitters. And you could have things like room heaters, coal fires, wood burning stoves. Any of these things would provide selective heating because they just generally heat the room that they are situated in. So the regulations, the key regulations for heating are Part L, and Part L is split into 4 parts: L1A, L2A, L1B, and L2B. And essentially, sort of these cover new or existing properties, domestic properties, or new or existing commercial properties. L1 is the one that is specific for domestic. Okay. Worth noting, water regs don't apply to heating systems, apart from obviously where the mains connects into the system. We need to make sure you use appropriate backflow, but apart from that, the actual heating system itself isn't governed by the water regulations. Building Services Compliance Guide. This is a document, a supporting document, which goes alongside Part L and basically describes how we can meet the requirements of Part L. And some of the key British standards to be aware of are BS 5449, probably not going to come up in your test, it's because it's been withdrawn, but it has come up in the past, and BSEN 442, that's the British standard for radiators. That one probably will come up. So we're going to look briefly at sealed and open vented systems, just like we did in hot water. The heating systems can be sealed or they can be open vented. Sealed systems are filled through a filling loop. This would be connected to the main supply pipe, and they would accommodate for expansion using an expansion vessel, or in the case of a fault, they would use a pressure relief valves. Good example another example of a sealed system here is the combi boilers. Combi boilers are always sealed systems, and they're both the hot side and heating would be filled from the mains. The heating would be filled from the mains via the filling loop. And combi boilers would have expansion vessels and temperature pressure relief valves built into the actual unit itself. Open vented systems would be fed from and vent to a feed and expansion system, so they are open vented, run at atmospheric pressure. Quick look at open vented heating system here. You can see the boiler here, with the primary flow coming off it here. Pump on the primary flow should always be fitted on the primary flow, and ideally immediately after the cold feed, which acts as the neutral point. There must be no valves fitted on a primary cold feed, and the minimum size for the primary cold feed is 15 mil. Primary open vent, minimum size 22 mil, would rise above the water level of the system, F&E system, by 450 mil, and that's essentially to prevent the surge from when the pump starts, causing it to pump over. And primary open vent should be 22 mil minimum, or a minimum internal diameter of 19 mil. Feed and expansion system, minimum of 18 litres. Though it can be bigger, it's fine if it's bigger. It needs to be big enough to take the expansion of the water in the system, which will be up to 4% of the volume of the water in the system. A couple of things worth noting: a primary flow and return are normally going to be 22 mil for gas or oil fired boilers, though if it's a solid fuel fired boiler, that minimum would rise to 28 mil. A key thing worth noting: the return from the cylinder must be the last connection to the return pipe, to this, what we might call the common return from where it joins. The reason for that is that the water coming back from the cylinder is still going to be really quite hot. It'll probably be about 70 degrees, depending on what temperature you've got your boiler set to, essentially. But it's normally going to be roughly 70 degrees, which means it's still really, really hot. And if, for example, we took our returning back over here, we're going to have really hot water running through this return pipe here underneath the radiators, which will cause this water to rise into the radiator through convection, which actually means that we can get our radiators heating up in the summer if we've put our return in at the wrong place. So it needs to be the last return into the common return before the boiler. Yeah, like I said, pump should be fitted on the flow just after the primary cold feed. It mustn't ever be fitted before the vent. You mustn't have any valves fitted before the vent. No valves fitted in the primary cold feed. They both act as safety measures to allow the water to expand. And then we would have a bypass fitted after the pump, before the motorised valve, between the flow and return to help protect the pump. And we're going to look at that in a lot more detail as we sort of move on through. I'll sort of give you a brief overview of some of the key things right at the start of the module, really, so we can build on that knowledge. Sealed heating systems, again, it's going to be pretty similar. You can see with regards to the pipe sizes and stuff, minimum 22 mil primary flow and return to the cylinder. We shouldn't have solid fuel connected to sealed systems because they're an uncontrolled heat source, so it's going to be minimum 22 mil. You can see the pump's still on the flow. We've still got a bypass there between our flow and return to allow the water to flow through and to prevent damage to the pump in certain circumstances, which we're going to talk about a bit later on. And again, our return from the cylinder should still be the last connection to prevent undue warming of the radiators in the summer. Expansion's taken up in the expansion vessel, and it would have temperature pressure relief valves fitted on there as well. So look briefly at gravity, semi-gravity and fully pumped systems. Okay, we touched on this in the cold water system module, sorry. It's a bit tricky, this terminology, you know, because you can talk about sometimes systems as being gravity fed, which means that essentially they are fed from a storage system. But we can also talk about sort of them as having gravity circulation, and that's when the water circulates as a result of convection. So it's sitting guilds use both of these terms in their exams sometimes, which can make kind of things a bit tricky, you know. So it's worth being aware of gravity. When we talk about gravity systems, it could be talking about being gravity fed, being fed from a storage system, but it could also be talking about the water circulates through the system as a result of convection currents. They might show pictures in the test of semi-gravity systems like the one shown left. You can see on the right hand side we've got our heating side, it's got a pump connected onto it, and on the left hand side, coming off the other side of the boiler, we have a cylinder with no pump connected to that circuit. And so as the water is heated, it would sort of rise up through this pipe, go through the coil, and then as it cools, it would start to fall back towards the boiler to be reheated. So that on the left hand side, our hot water side, is circulation is a result of gravity, and on the right hand side we've got our heating, which is pumped. It's very, very slow and inefficient to use convection to transfer heat, so we wouldn't install semi-gravity or gravity systems from new anymore. And actually the recommendation is to swap them over into fully pumped systems if you do come across them, but they are minimum requirements, which we're going to talk about in a second. But one thing worth noting with our semi-gravity system, you can sometimes have the return from the cylinder coming back into the common return, the pumped return, and if they're not always like this with two separate circuits. They can sometimes be a bit more like this. So you have this return coming back in here, and you have pumped water travelling quickly through the return here, and that can make it sort of problematic with regards to convection. It can sort of prevent the water from convecting through here, and sort of slow down the quite inefficient sort of heat transfer process even more. So what's recommended if you do have a return going into from a semi-gravity system, coming from the convected part to the pumped part, you should fit an injector T. And an injector T looks just like this picture up the top here. And the way it works is, you can see the second picture down here. You've got this pumped return, and the water's going to be travelling fairly quickly through there. But what they do is they put a sort of nozzle inside the fitting, which sort of reduces the size of the pumped section, and that actually can cause the water to be drawn through more quickly on the convected side. This water speeds up and it's going to sort of shoot along here and sort of pull some of that convected water along and through with it. So minimum requirements when working on a semi-gravity system. If you do work on a semi-gravity system, you should, as an absolute minimum requirement, fit a heating control. This thing here, it's called the thermomechanical valve, and that's to prevent the water heating up too much in the cylinder and sort of it becoming scaldingly hot. So the recommended thing to do is actually upgrade the whole system to fully pumped. So yeah, we shouldn't fit this system for new anymore. It's set out in Part L in Building Services Compliance Guide. what we should do, any systems that are fitted from here on in should be fully pumped systems, and with the appropriate controls described as boiler interlock, which we're going to look at now, and we've got a whole kind of section on this a bit later on in this session as well. So boiler interlock, you should have a temperature control, so these things here, thermostats and thermostatic radiator valves, and a room thermostat as well, so cylinder stat if there's a cylinder fitted, a room thermostat, and TRVs, or thermostatic radiator valves, on all the radiators apart from any radiators in the room that the room starts in. Okay, if there's a cylinder fitted, it must be fitted with a cylinder stat, and they must have a means of sort of pumping the water around and controlling where the water goes to. So obviously a circulating pump should be part of boiler interlock, and a motorised valve, we've got a 3-port valve here shown to control which circuit it flows into, or both circuits potentially, depending on what type of valve fitted. And we also need something to control the time when things come on, when things go off. It's all about ensuring the system is as efficient as possible. So the components that make up boiler interlock: time control, normally a programmer, thermostat, should be a room stat or cylinder stat if it's fitted, pump, motorised valves could be 2-port or 3-port, we're going to look at that in a lot more detail a bit later on, and thermostatic radiator valves. So these are all the key parts. Okay, so now it is time for your task.